Hello, Science Fam. We are working on stoichiometry problems, and right now, with the development of our newer mole map, where we can convert from moles of one object to moles of another, we've just opened up a whole new range of different types of problems that we can do and we can tackle. So let's jump into it and get some more practice. This is from our worksheet number 2. I'd like to do the first couple examples with you if you need the help. Now, first of all, before we can do anything with moles to moles, meaning a stoichiometry problem, we have to make sure that we do have a balanced equation. So if I look up at the top here, I've got my aluminum oxide is going to break down and decompose into aluminum and oxygen. I have 3 oxygens on the reactant side and 2 oxygens on the product side. So in order to make those equal, I need to make them both 6. So I'm going to multiply this by 2 and this by 3. Now the good news is I have 6 oxygens on both sides, but this also created 4 aluminums on the reactant side. So that means I am going to need to put a 4 there. But now I'm balanced with a 2-4-3 ratio. Okay, now that I have that balanced equation, I can start tackling question number 1. So I have 15 grams of pure aluminum. It's produced, it says. So how many liters of oxygen will also form? All right. So let's think about that. First of all, I'm given that I have 15 grams of aluminum. And eventually, I want to figure out how many liters of oxygen. So notice a couple things that are important. First of all, you're starting in aluminum and you're ending up in oxygen. So that means that you will have to deal with moles of one object to moles of another. Okay, the thing that I'm starting with that I have information for is like my object A, and the thing I'm going to end up with, if it's a new object, I'm going to call that object B. So since I'm starting with mass of object A, I'm going to start in my very first island, mass A. Now since I'm going to end up in liters of a new object, that means I'm going to end up in volume, but not volume A, because that would be aluminum. I'm going to end up in volume B. So I'm going to end up down here at this island. So notice that I'm going to start at this island and end at this island, which means I have a path to take. I'm going to have to go from mass A to mole A. And once I'm in mole island, I'm then going to have to jump over to mole B island. And once I'm in mole B island, I'm going to go to volume island for volume B. So that means that's going to be a 1, 2, 3-step problem. All right, and as long as we follow the map, we should have no problems whatsoever. So let's do that. Let's write down what we have. First of all, I've been given 15 grams of aluminum. Now, my first step is going to be going from mass A to moles of A. To do that, it says to put 1 mole over molar mass, something we've been working on and doing quite a bit. So since I'm talking about aluminum, I'm still going to have 1 mole of aluminum on top, and molar mass on the bottom means I'm going to take that mass from the periodic table. Now the molar mass of aluminum off the periodic table is 26.98 grams. 26.98. Okay, now that is my first step. Before I move on to my next step, which will be nice to do, let me make sure that my units are going to cancel out and I'm going to head where I need to go. So grams of aluminum and grams of aluminum units are diagonal to each other. One's in the numerator, one's in the denominator. So that means they're going to cancel, which is good, because now I'm left with on top moles of aluminum, and that's where I should be because I ended with the island mole of A. Now I'm good there. I need to carry on, which means I need to go from moles of A to moles of B. Now this is something we've been working on newer, but notice it says B moles over A moles. And this is where this comes in, where I labeled my aluminum A and my oxygen B. So B goes on top. So since B is oxygen, I'm going to put moles of O2 on top. And since A was aluminum, I'm going to put moles of aluminum on the bottom. Again, why? Because my mole map says to do B moles over A moles. Okay, now I don't have any numbers there, but that's okay. I'm just going to use those numbers from the balanced equation. So B moles is O2 oxygen, so I'm going to look at oxygen in the balanced equation, which is 3. For aluminum, in the balanced equation, there's a 4, which means 4 moles of aluminum for every 3 moles of oxygen produced. Great. Now let me double check my units. Again, diagonal to each other, moles of aluminum and moles of aluminum are there, and they cancel out. So this means I'm ready to go to my third and final step. My third and final step, since I'm in mole B island, I'm just going to simply go to volume B island, which means going from 22.4 liters of moles on top, 22.4 liters to moles on the bottom. Said that in a goofy way. Sorry about that. Now, because I'm still in object B mode here, I've already converted over from aluminum to now oxygen. Now, everything after this island has to do with oxygen because I converted to it. So I'm going to put that right there. Now that I do that, I double check my answers and my units. Moles of oxygen cancel out, and I'm left with units of liters of oxygen, which is great. Why is it great? Because that's exactly what I was looking to solve for, liters of oxygen. So if you didn't have a game plan, if you didn't know where you start and where you end, you'd have no idea that you had to go from mass of A to moles of A to moles of B, and moles of B to volume of B. It would be very confusing. So make sure you do pay attention to where you're starting and where you're ending and follow the map. All right, now that we've done that, we can multiply that all out. Please don't forget that you always start with the number you're given, so 15 grams. You would then multiply the top, so times 1. Always divide by the bottom, which is divided by 26.98, times by the top, times 3, divide by the bottom, divided by 4, times by the top, 22.4, divided by the bottom, which is 1. When you do that and you throw that in your calculator, the answer you end up with is going to be 9.34 liters of oxygen gas. Now, make sure you throw that in your calculator. Don't just take my word for it, but make sure that that's correct and that you are putting in your calculator right. If you do that, which is good, you then are checking, hey, not only can I set up the problem right, but also am I putting that in my calculator right? So, nice job. All right, let's take a look at question number 2. We want to know how many liters of oxygen will form. So eventually I'm looking for liters of oxygen. That looks like a volume. How many liters of oxygen will form from 100,000 formula units of aluminum oxide? Okay, so first of all, let's see what we have. We have 100,000 formula units of aluminum oxide. Great, that's what's given to us. Okay. But we want to convert that to, as it's saying, liters of oxygen. All right, if you take a look, there's different compounds. You have aluminum oxide, and eventually we're converting to a new object, which is oxygen. So we have an A and a B. So that means when we use our mole map, we are going to transfer over from A to B. So let's map that out. First of all, I'm starting with 10,000 formula units of aluminum oxide. So formula units, that falls under particles, A, right? But I want to end up with liters of oxygen, which is a completely different compound. So that means I'm going to end up with liters, which is volume, but that's a new substance, so I'm going to end up at volume B. But now that I know my beginning and my end, I can just follow my map. So I'm going to go from particles of A to moles of A. And then I'm going to go from moles of A to moles of B, and then from moles of B to volume of B. All right, now that I have my steps, it does look like I'm going to have 1, 2, 3 steps in order to get to my answer. But no worries, we'll take one at a time, and we already know how to do each individual step, and we'll just put them all together. So let's do that. First thing I always do is I'm going to start off by writing what I have. So I have 100,000 formula units of aluminum oxide. Okay. Now, step 1, I'm going to go from particles of A to moles of A. To do that, it says to put 1 mole over Avogadro's number. So I'm going to put 1 mole, that's of aluminum oxide, Al2O3, over Avogadro's number, which is 6.02 times 10 to the 23rd. And that's going to be formula units of aluminum oxide. All right? Sorry for my small writing. Just want to make sure I fit that all in. Now, before my next step, I just want to double check to make sure my units are going to cancel out. So diagonal to each other is formula units of aluminum oxide, which is good, leaving us behind moles of aluminum oxide, which is what we were trying to solve for. So that's good. My next step is to go from mole A island to mole B island. To do that, remember, we're going to take B moles over A moles. And since we already noted that in the beginning, the B mole, the thing we're looking for, is oxygen. So according to this chart, we're going to put moles of oxygen on top, and A we know is what we started with. We're getting rid of, so we're putting it on the bottom, moles of aluminum oxide on the bottom. Now having that on top and bottom is great, but we don't have any numbers. Where do those numbers come from? Remember, at that step we use the balanced equation. So in our balanced equation, there's 3 moles of oxygen, so we're going to put a 3 there. And on the bottom here, aluminum oxide, there's going to be 2 moles of aluminum oxide. So we put that on the bottom. Now that we have that, we can double check our units to make sure things are canceling out, and indeed they are. You got rid of moles of aluminum oxide, which is important because now we're in moles of oxygen, and that's where we need to be in order to get to the last step, which is solving for volume of B. All right, to do that, no problem. The last step is simply, as it says, to do 22.4 liters over 1 mole, and that's what I'm going to do. 22.4 liters over 1 mole. Just don't forget, since we are dealing with object B is oxygen, so we want to label both of these, liters of oxygen and moles of oxygen. Now keep in mind, we want to double check one more time to make sure that moles of oxygen cancel out because they're diagonal to each other, and they are. So the units that are left over are liters of oxygen, which is great. That's what we're trying to solve for. So if we throw this in our calculator, remember the whole idea is to multiply by the top, divide by the bottom. So I'm going to throw 100,000 in my calculator. I'm going to multiply by the top, so times 1. I'm going to divide by the bottom, which is 6.02 times 10 to the 23rd. I'm going to multiply by the top, times 3. Divide by the bottom, so divide by 2. Multiply by the top, times 22.4, and divide by the bottom, which is divided by 1. When I do throw that in my calculator and get out an answer, I'm going to end up with about 5.58 times 10 to the negative 18th power, and my units will be liters of oxygen. Now if you think about it, 10 to the negative 18th power is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 1, 8. It's that small of liters. It's incredibly small. Why is it such a small number? Well, remember, you only started with 100,000 formula units, okay? And if you think about how ridiculously small atoms are, 100,000 formula units of aluminum oxide really isn't that much. In fact, it's so small we wouldn't be able to really see it with our naked eye. So it makes sense that when we use that and we actually convert that and decompose it into oxygen, it makes sense why there's such a small volume of it. It's ridiculously small because there's barely any formula units. So even with 100,000 formula units of aluminum oxide, you end up with a super small volume of oxygen. So pretty crazy to think about. But hopefully these 2 examples did help you further in understanding some 3-step problems with the mole map. And we call this stoichiometry because we're converting of moles of one object to another using our balanced equations. All right, science fam, thanks for hanging in there. Hopefully you're feeling a lot more comfortable and can do some on your own. Best of luck.